Hello everyone, welcome to this video. In this video, we are going to solve a problem called check for BST from Geeks for Geeks. In this problem, we are given a node of a binary tree and we need to check if it is a binary search tree or not. We are given some rules. Based on these policies, we can check if this binary tree is a BST or not. Let us read that. The left subtree of a node contains only nodes with keys less than the node's key. For example, this one is part of 2's left subtree. So this all the node of 2's left subtree must be smaller than 2. The first statement is like this. Second statement, the right subtree of a node contains only nodes with keys greater than the node's key. For example, all these like 3 and 5, these are right subtree of 2, so they must be greater than 2. Okay. The third statement, both the left and right subtree must also be a binary search trees. For example, the left subtree, that is 1 must be a binary search tree. We need to check for 3. Is 5 greater than 3? Yes. If it is, then 3 is also valid. 3 has no left child, so no issue. For 5, we will check if 5 is a valid binary search tree or not. So 5 has left subtree, left is a null, right is also null, so it is also valid. And whole, not only just parent node, but also the left subtree and right subtree is also binary search tree, so the answer is true. Let us see another example. In this example 2769, there are no left node, it is skewed tree. So all the nodes are in one direction. So for 2, we need to check if the right subtree, that is 769, are greater than 2 or not. Yes, they are greater than 769 are greater than 2. So this is for this node it's valid. Let us check the right subtree is valid or not, which means the 769 is a valid subtree, binary search tree or not. So for 7, the right subtree, which is 6 and 9, must be greater than 7, which is not. 6 is smaller than 7, and 6 is lying in the right subtree of 7, which means it's wrong as per the second statement. The right subtree of a node contains only node with the keys greater than the node's key, which means the right subtree 6 and 9, which are right subtree of 7, then 6 and 9 must be greater than 7, which they are not. 6 is not greater than 7, so we return false. Okay, check this last example. In this 10 5, this is also returning false. So let us see why it is returning false. For 10, the left subtree must be smaller than the 10 itself, right? So 5, which is right. So 5's left right does not exist there, that they are null. So let's go back and see for right subtree of 10. So for right subtree of 10, we have 20, if 29 and 25 are valid binary search tree or not. So for 20, we have 9 in the left of the 20, which is valid, and 25 in the right of 20, which is valid, but the condition says the right subtree of a node contains only nodes greater than the node's key. So this right subtree 29 and 25 are right subtree of 10. What does it mean? It means 9, 20 and 25, these three nodes must be greater than 10. So since 9 is not greater than 10, this is invalid, which again, as I said, the right subtree of a node contains only nodes greater than the node's key. So this is like this right subtree of 10, which is 29 and 25, this all these nodes must be greater than 10, right? So since they are not greater than 10, this 9 is not greater than 10, we will return false. Now the question is, how would we implement this? Can we just say we will stand in a node and we'll check if my left is smaller and right is greater? Then we will return true, and we will do a recursive call in left subtree, a recursive call on right subtree, and return the answer. Would we do this way? No, this would be a wrong approach. Let us see why. Can I say this is the invalid tree? Let us see. Can we say if we are at 10, we'll see my left is smaller, my right is greater? Yes. So let do a left call for left subtree, And for left subtree, now we are here at this node. This is our root now, and we'll check if my left is smaller, yes. If my right is greater, yes. And we'll check. We'll again call for left subtree and right subtree. For left subtree, we'll see one has null. It has both left right null children. So we'll go back. We'll come to 5. We'll go towards right. We'll see my left child, right child are both null. Then we go back. We came to 10. We'll call on the right subtree. We'll see for 15. My left child is 14. Yes, that is right because it's smaller than 15. And my right child, which is 20, which is greater than 15. So as per the logic, if we check just children of my current node, we can't solve the problem because this is invalid BST based on this. Can you see the statement? The left subtree of a node contains only nodes with keys less than the nodes key, which means all these nodes, this 5, this 1, and this 12, this must be smaller than the 10 because they are part of 10's left subtree, and this is invalid VST, right? How to code it? Like this method is failed, right? Which we just thought that we will simply check for left and right children, and if they are valid, we will make a recursive call for left subtree and right subtree, and this way we will solve it, right? No, this is wrong. So let us come to the correct solution, correct approach. So what we can simply do for this tree, let's see this tree. Can we say that this 9 is at wrong position, right? This 10 has the right subtree, which is 29, 25, and this 9 is should not be in the right subtree of 10, right? So how we have verified it? Can we say that we will simply have a range? We'll simply take a range of two numbers, and we'll make sure every node must be in between them. For example, this 9 must be between 10 and 20, right? It should be greater than 10 because it is lying in the right subtree of 10. Okay, and it must be smaller than 20 because it is lying in the left subtree of 20. Can we say this? Which means this 9, sorry, not exactly check if 10 is in range, but in range of what? 10 is parent, 10 doesn't have its parents, right? So for 10, can we say that it should be range in like in between negative infinity to positive infinity? And then for 5, we'll come to 5, we'll see if 5 is in between, it is 5 in between range of negative infinity to 10. Why negative infinity? Because there is no like no subtree, it's part of left subtree of 10, so it must not be greater than 10, it must be smaller than 10 itself. So range for 5 would be negative infinity to 10, right? And then 5 doesn't have any children. Let's go to right. For 20, let's say for 20, 20 must be in the range between 10 to positive infinity. Why? Because 20 lies in right subtree of 10. So 20 has to be greater than 10. Let's go for 9. We have already checked for 9. We will check for 25. For 25 has to be greater than 20 and less than positive infinity. Why positive infinity? Because there is no upper bound for 25 here. 25 just does not need to be less than 20. That's it. So when we go left, we have like upper bound. When we go left, we have upper bound, which is this root, and when we go right, we have lower bound, which is root, right? So root is upper bound for left subtree and lower bound, like lower limit for right subtree, which means for 5, 10 is the maximum value it can get. 10, 5 cannot be greater than 10. For 25, 20 cannot be if 25 cannot be smaller than 20, it has to be greater than 20. I hope I'm making sense. I'll write code for it, and then we will easily explain understand it. So give me some chance. So let me just code it right. This is the given method, and since this method is not allowing us to write ranges, so we'll write our custom function. Let me write it. Boolean is BST helper. I'm creating it helper. I'm calling it helper node root int min, min int max. We have defined our min and max range, but we will say if node is null, root is equal to null. What if it is null? What will return, false or true? What will return, false or true? If null node cannot be false, for example, the any number, if we write any number 10 to the power 0, if 10 to the power y is 1, it's not 0 but 1. Why? So many things are predefined, we can't change it, it must be true. Like if a node is null, we have to return true, we can't return false here, because it would be false. There is no reason of returning false, so just like keep in your mind, if node is null we have to return true. Right, it is exactly how we can say anything having 0, like anything raised to 0, 10 to the power 0 is 1, any number to the power is 0, sorry, is 1. Why? We don't know. Same way, we don't know why. If any node is null, we have to return true. If a binary search tree, if a binary tree has a null node, it is true, it's truly a BST. Let's see, let's check for check if any node, let's say if any node is invalid or not. If it is invalid, we will simply return false, root dot data. If it is outside range, any node which is outside this range, we will return false, simply. So if it is smaller and equal to, check the or data is greater than equal to max, return false. Now let me ask you one question. Why we are saying less than equal to? We could have said less than. Why we are saying less than equal to? Or we could have said greater than max. Why we are saying greater than equal to max? Why equal to is there? It's because here node duplicate nodes are not accepted. We are considering that BSTs cannot contain duplicate nodes. Are you getting the point or not? If a BST does not contain a duplicate node, so like this 2 cannot contain duplicate node another in the left or right. So if there is a duplicate node, which means if 2 is the maximum limit for 1, right, in the range, and one we compare this node with its parent, which is 2, and they both are 2, so we need to return false. That's why we are using this equal. I hope you understand why equal is there, right? Duplicate nodes, to deal with duplicate nodes we are writing equal there. Now let us check for left subtree valid BST. We are checking if our left subtree valid BST, and then we will check is right subtree valid BST, right? How would we check? We'll simply call and call. So root dot right, here we will call root dot left. Now see the difference. How would we update the range? Like for 2, the range was negative infinity to positive infinity. For 1, sorry, for 5, for 10, the range was negative infinity to positive infinity. For 5, the range would be negative infinity to 10, which means the minimum range will remain there, maximum will change, the maximum would change to parent, which is 10. What is the parent in this code block? What is the parent is the root. The node we are given is the root. For the left subtree, the current node is the parent, so root dot data. Okay, max we have given. Okay, for let's say right subtree, when we are calling the right subtree for 20, let's say for 20, what is the lower bound? What is the lower limit? The minimum value 20 must have, at least, like minimum. The minimum would be 10, the parent. So minimum should be replaced by root dot data. The parent, for left subtree, sorry, for right subtree, the parent, which is the current node, is the lower limit, is the minimum, right? And what is the maximum for 20? Maximum could be anything, whatever coming to us. Maximum would remain as it is, like we won't change maximum. Okay, and finally return and of both of them. Why we are returning and of both of them and not all of them? Why not or? Why And because we want to make sure that both left and right are true or false. Even one subtree, let's say left subtree is true and right is false, we will return false. If left is true, right is true, then true. If left is false and even right is false, like left right both are false, then we will return false. And that's why in this situation we use AND operator. Okay, let's go. Return is BST helper. We write root, and what is the minimum range? Minimum range for the parent would be int, sorry, min value and integer dot max value. Is that fine? Let us run it and see if it works or not. Let's see. Yay! So it works, right? Let us submit. If we could submit it successfully or not. Oh, very fast. Yes, so we have successfully solved this problem. Check for BST. I hope you guys like this video, and this is the first video of my channel. So I want you people to like support me. It motivates me a lot. So thank you so much for watching this video. If you have any doubts, put it in the comment section. I'll try my best to reply you. Bye and take care. Thank you so much for watching.